Each phase of the conflict lasted roughly 12 days. Now a rather unusual situation has emerged. Both sides are claiming victory. The United States has publicly stated that the war has already ended and that Iran's air force and navy have been effectively destroyed. Meanwhile, Iran insists that it still retains the ability to retaliate and has even declared that it may deploy missiles with warheads weighing no less than 1 ton. These conflicting statements from both sides have made the situation confusing and contradictory, leaving outside observers unsure about what the real outcome actually is. In reality, the situation may be far more complicated. If we look back at the first day of the conflict, many people believed that Iran was already on the brink of collapse. This was especially the case after its air defense systems suffered severe damage. So how did the US-led coalition manage to cripple Iran's air defense network so quickly? The answer lies in one crucial factor: electronic warfare conducted by the US military. The core purpose of electronic warfare is to paralyze the enemy's radar and air defense networks. In this operation, the Boeing EA-18G Growler played a central role. Months before the conflict began, the US military had already started collecting data on Iran's radar systems. Extensive electronic reconnaissance missions were carried out to map radar frequencies and identify the locations of key radar installations. Once sufficient intelligence had been gathered, all of this data was fed directly into the targeting systems of the EA-18G aircraft. Every jamming pod on the aircraft could then be controlled through this system. The officer seated in the rear cockpit is the electronic warfare operator, the key figure responsible for executing the jamming tactics. Using radar sensors and electronic intelligence systems, the operator selects the most effective jamming method for each situation. When the sensors on the EA-18G detect the frequency of an Iranian radar system, the aircraft can emit powerful electromagnetic signals, sometimes exceeding 10 kilowatts, directed precisely at the radar target. This surge of energy can overwhelm the radar's signal processing system, effectively blinding the entire air defense network for a short period of time. In addition, the EA-18G can generate false signals that simulate an entire squadron of fighter jets. This tactic not only disables Iran's radar systems but also creates significant psychological pressure. The aircraft intercepts radar signals from Iran, alters the data, and then reflects the modified signals back along the original path. On Iranian radar screens, dozens of Phantom aircraft may suddenly appear, seemingly rushing toward their airspace. Faced with this scenario, Iran may launch multiple surface-to-air missiles, yet many of those missiles end up exploding harmlessly in empty sky. Even when Iranian missiles successfully lock onto a real aircraft, the EA-18G has countermeasures. It can simulate the speed and position of the targeted aircraft, creating a decoy signal. If Iranian radar systems lock onto the decoy, the EA-18G can maneuver the false signal away from the real aircraft's position, causing the tracking system to chase the fake target while the real aircraft safely withdraws from the danger zone. However, electronic warfare also has its limitations. There is a dangerous area in electronic combat often referred to as a threat zone. If American aircraft approach Iranian radar installations too closely, typically within a range of about 32 to 97 kilometers, the radar's signal strength may overcome the jamming interference and successfully lock onto the aircraft. For this reason, EA-18G pilots must perform extremely precise tactical maneuvers, maintaining their position near the edge of the threat zone. The U.S. electronic warfare process typically begins with identifying the electronic signatures of Iranian radar systems, their deployment locations, and their communication methods. All of this information is compiled into a digital strike list and uploaded into the EA-18G's core operating system. At command centers, military planners construct a three-dimensional combat model, defining the threat radius of each Iranian missile system and marking safe aerial corridors for aircraft operations. During the attack phase, EA-18G aircraft circle around the battlefield area, continuously transmitting jamming signals while avoiding detection and engagement by Iranian radar systems. The entire operation functions like a precisely engineered machine. EA-18G squadrons handle electronic suppression, while strike aircraft such as the Lockheed Martin F-35 Lightning II and the Boeing F/A-18 Super Hornet carry bombs and conduct the actual airstrikes. Approximately 30 minutes before reaching the target, EA-18G aircraft begin large-scale jamming operations from a distance of 80 to 160 kilometers. At that moment, Iran's early warning radar screens may appear as if they are covered in a dense electronic fog, causing Iranian forces to lose awareness of the developing battlefield situation. 15 minutes before the strike, the attack aircraft enter the combat zone while EA-18G aircraft shift from wide-area jamming to precision interference. False targets are injected into Iranian radar displays. With altered speed and distance data, radar operators are suddenly flooded with confusing signals, making it extremely difficult to distinguish real aircraft from fake ones. In this situation, Iran faces a difficult dilemma. If radar operators increase the radar's power in an attempt to penetrate the electronic interference, they effectively reveal their own location. American aircraft can then launch anti-radiation missiles that home in on the radar signal and destroy the installation. But if Iran shuts down its radar to avoid detection, the entire air defense network becomes effectively blind. Furthermore, EA-18G aircraft can interfere with communication links between missile batteries and central command centers. Even if some Iranian units detect American aircraft, they may be unable to obtain launch authorization or send warnings to other units. As a result, many Iranian air defense positions become isolated. After the bombing mission is completed, the strike aircraft descend to lower altitudes to withdraw from the area. This is the most dangerous stage of the mission, because the aircraft are slower and more vulnerable to attack. During this time, EA-18G aircraft continue to release intense electronic interference, keeping Iranian radar systems in a state of disruption until all aircraft safely exit the area. Nevertheless, although the US-led coalition gained significant advantages through advanced combat systems and electronic warfare technology, Iran's military capabilities cannot be underestimated. Satellite imagery later revealed that several US military facilities in the Middle East also suffered damage. Some missile defense systems, including the THAAD, were reportedly destroyed. In response, the United States had to deploy additional THAAD systems from South Korea to reinforce defenses in the Middle East. All of this suggests that although advanced technology provides a major advantage on the battlefield, the confrontation between the two sides remains complex and uncertain. Even now, the true outcome and full impact of the conflict remain unclear.